To all of you. Am I audible? Can you please confirm it? Yes, students. Yeah. Good evening. Yes, students. Today, I hope you are executed previous programming. You executed previous programs. I hope all of you. Yes, ma'am. Tomorrow there is a class. Tomorrow there is a class because today locking concept will be over. Multi-threading concept will be over. Tomorrow morning, I will introduce the last topic. That is a multi-threading I will be completing today. Locking concept I will be explaining. Tomorrow, networking topic, last topic that will take 2 days. Tomorrow, I will take the class at 7 o'clock morning. 7 o'clock, I will take the class. Okay. And Monday will be the last class. Sunday, Monday. Actually, I want to take Monday, Tuesday. And I want to, because all of you listen, when I come to the office to the home, it will take a lot of journey. Of course, networking will be taken 2 days. So because tomorrow I'm free Sunday, na, morning time, I can take comfortably. Because Monday, if it is a late, it is a problem for you. That's why Monday, 10 to 15 minutes late, don't mind. I will tell you the Monday timing also. Instead of 6 o'clock, I will just go for 6:30, we will take it. Yes. So tomorrow class, Sunday class always 7 o'clock, my dear students. Please understand me. 7 o'clock always. So Sunday class is always 7 o'clock. Fine. So dear students, let me start the discussion about the topic called what? Locking. Locking concept I want to introduce. So let's start the locking scenario in the multi-threading. Right. Shall we start, students? Yeah. Yes, ma. Last class notes not uploaded. Huh? Okay, I will upload, ma. I will upload. Not a problem. Today I will upload it. Yeah. Locking concept I will introduce. Actually, this is one of the operating system concept. What is it? Let us start the topic name like this. Synchronization concept. Synchronization concept in multi-threading. So, or locking and unlocking concept in multi-threading. Locking and unlocking concept in multi-threading. Okay, let us see locking and unlocking. Locking and unlocking. Unlocking concept in multi-threading. Okay, multi-threading. Fine, students. Let us start with a very simple thing. Let's go. So let us see, students. So far, what we did? How many threads we created? We created a thread. Creating a thread is easy. And then, yes, ma'am, Amitabh. This is a last topic in multi-threading. Yeah. So let us start with, let us assume there exist previous scenarios. We created multiple threads and multiple run methods are there. So the model 1 application says something like this. Observe, my dear students, all of you. So here I am taking model 1 application, what we learned it. This is one method. This is called another method. This is called another method. Carefully understand. This also you need to get it so quickly. So this is called the method called X method. This is called X method. This is called Y method. This is called Z method. This is called K method. This is called K method. I created the threads. How I created that? T1 is equal to thread of target is equal to target is equal to x. Target is equal to x. Okay. Now T2 is equal to thread of target is equal to target is equal to y. T3 is equal to thread of target is equal to z. Next T4 is equal to thread of target is equal to k. Target is equal to k. Okay, k. These are the threads what we have: T1, T2, T3, T4. T1, T2, T3, T4. Now I want to execute this. What we did later, T1 dot start. Later I did T1 dot start, T2 dot start, T2 dot start, T3 dot start, T3 dot start, T4 dot start, T4 dot start. These are the things what we did. What is happening that time? It will be coming to the threads are coming to the T1. T1 is coming to X method. T2 is coming to Y method. T3 is coming to Z method. And T4 is coming to K method. Am I correct? Am I correct? Yes. So threads are executing. These things are executing safely. This entire thing. They are executing in their own place. So this is executing. X method is executing safely. And Y method is executing safely. Y method is executing safely. Y method is executing safely. Z method is executing safely. X method is executing safely. Y method is executing safely. Y method is executing safely. And next is called what you know? K method is executing safely. K method is executing safely. And there is no interference in any one of the place. So during this execution, I got the result. Result I got it. Result I got it. Result I got it. Result I got it. I got the result approximately. I got the result of these kind of things. Well, dear students, if you carefully follow me, the threads are not interfering to each other safely. Like 4 people are running in the running race. 4 people are going parallelly in their runway. Just imagine students running in there. This is called model number 1. This is called model 1 application we can call. Okay, students. Model 1 application it is called. Model 1 application development it is called. Next I'm going to model 2 application. Next I'm going to model 2 application. Next I'm going to model 2 application. I want to go for it. What is the model 2 application here? Model 2 application here. What is the model 2 application now? What is the model 2 application now? Coming to the point of it, here, I want to go for model 2 application now. See that here, only one method is there. Carefully understand, my dear students. Only one method is there. Observe the difference between model 1 and model 2 carefully. Model 1 application is available. Next, there I am going to take it. Multiple threads are created. What is the method name here? X method. X method this is. X method this is. Fine or no? X method this is. Now here, what I am having here is, there I am just taking X method here. I am saying that X method I am taking. You observe it here. I am taking Z method. Like this I am having. Like this I am taking. So here X only, here also X, here also X. Look at students, right? All multiple threads are created and all of them are entering into T1 dot start. Understand, ma? T1 dot start. T1 dot start. Next T2 dot start. T2 dot start. T2 dot start. T3 dot start. T4 dot start. T4 dot start. T4 dot start. When I say T1 dot, T2 dot, T3 dot, T4 dot start. T1 dot, T2 dot, T3 dot, T4 dot start. What is happening? See students. So T1 is entering, T1 is entering, T2 is entering, T3 is entering, T1 is entering, T2 is entering, T3 is entering, and T4 is entering. T4 is entering. So it is going to be given as T1 is entering, T2 is entering, T3 is entering, and T4 is entering. Then can you imagine what will be the result of it? Can you imagine the result of these things? All the threads are entering at the same time into the same resource at the same time. Can you imagine what will happen? Can you imagine what will happen once? Dear students, start. What is the result you are going to get it? All the people, see, one running race lane only available. Hundreds of people allowed into the same running race channel. What will be happening? Are they going to decide the output? They are going to fall on each other or not? Because of their interfering to each other or in the single method, they are all entering into the single method. All of them are entering into the single method. Or on the single object they are entering. Operations are performing on the same object. Operations are performing into the same object. Operations are performing on the same resource in general. Operations are performing in the same resource. I'm talking about same resource. I'm talking about what, ma? Same resource I'm talking about. Same resource they are entering. Because of that, what is happening? The things which are entering inside, we can't predict, we can't expect the result out of that. We can't expect, see, we can't expect the result. We can't expect the result from the above execution. From the above execution, such a type of results are called deadlock result. We can call deadlock result. We can call deadlock result. Also called as what, such a type of results are called a deadlock result. Such a type of results are called a deadlock result. Also call it as, look at. We can eliminate this deadlock result by using locking concept. Yet it is available. It is useful. That's what I'm saying. That's what I'm covering it. Imagine Ram, Mono, all of you. See, you take Gmail. Gmail is called one application only. How many people are accessing? Ma? Across the universe, millions of people are accessing, entering into the same website. Are we getting any deadlock result? No. So this is also known as what, this is also known as a race condition. We can call So the Google Gmail people has managed that multiple clients are entering at the same time. They managed it by applying the locking concept. What is happening? You see, one more time, traffic signals, you take it, traffic signals. When it is junction is there, junction is nothing but it is a resource where it is a junction, intersection point. If all four sides vehicle are occurring at the same time, Simultaneously, if all four sides vehicle are coming at the same time, what will happen? What will happen when four sides vehicles are coming at the same time? Some unexpected situation will happen. Is it an expected result? It is called a deadlock result. Unexpected result. It is called a race condition. Due to multiple threads are occurring in the same resource, due to multiple threads are colliding, and collision is happening in the same method, we are getting the wrong results. Such a type of wrong results are called what? Deadlock results we can call, or race condition we can call. Such results also called as what? Non-thread safety result we can call. Non-thread safety. Non-thread safety result we can call. Non-thread safety result we can call. Non-thread safety result. Such a type of thread safety result to avoid, such a type of to avoid, dear students, carefully understand, to avoid, what is it? To avoid, to avoid such a type of deadlock result, to avoid such a type of deadlock result, we must apply, we must apply what? We must apply which concept? Locking concept we need to use it. We are using that Omkar, we are using. Locking concept we are using. Locking concept. What is the locking concept says? Allow them, allow all the people at a time. But internally, the locking manager, the PVM will allow only one thread at a time with the difference of milliseconds of time. Actually, all of them are allowed at the same time. But what is happening? They are allowed to do the operation in terms of milliseconds of time. If you do the operation hour by hour, it is called sequential. 1 hour you are doing, later 1 hour I am doing it. Next is what? If you do second by second, after 1 hour by hour, it is too much time is taking. If you do minute by minute, it is taking too much time. If it is taking what? If it is taking what? Minute by minute, compared to hours, minutes is better, faster. Instead of minute, we are going to use seconds. Seconds also going to be called what? Too much fast in execution. You have seen already in our class, threads are executing in terms of what? Seconds of time. Some seconds, fraction of seconds you are performing, coming out. So what is happening? Due to the locking concept, we are going to avoid such type of deadlock result. Tell me, students, wrong result is better. Wrong result is better. Getting the result with the good result is better. Getting the result is better instead of deadlock result. Can I show you one program on this area? What is the situation? Understand model 1 and model 2. First of all, students, did you understand this concept first of all? Did you getting this awareness first of all? This is called model 2. Model 2. First you understand the model 2. Understand the model 1. What is the model 1? Model 1 is called 1:1 ratio. 1:1 ratio. One thread, and then one thread, and then one thread, and then one method. One thread and one method. That is 4 threads are there, 4 methods are available. Here what is happening? Multiple threads are there. Multiple threads are there. Multiple threads we have. And then next we are having what? Multiple threads are there. And what we are having? Single method is available. Single method is available. That is called many to one. Many to one always gives you collision. Many to one always gives you collision. Collision will give you wrong results, students. So many is to one. I am writing many is to one. That is a multiple threads is to single method. See that is to symbol I am writing here. So dear students, I hope that you are understanding me. Multiple threads is to single method always gives you the deadlock result. Can I show you the operation once more? Can I show you the program once so that you can understand more better? More better you can understand. Shall I show you the program? Yeah, with example only we can go for it. Right. Okay. Omkar, you are giving good example, but don't tell to anybody else because the people will fight with you. Hmm? Right. Hmm? Don't tell to anybody. Okay. Even I am not saying in the class. Okay. Right. Huh? Saifuddin, don't worry. Don't worry. Don't worry. Okay. Yeah. Right. Right. So so coming to the point of it. So it is something like what I interpret his example, not exactly I'm giving his example. There is a simple doll is there, a balloon is there, a balloon is there, right? A balloon is there. And I'm allowing four kids to take that balloon. What will happen? The balloon will be, four kids are allowed at a time to use that balloon. What will happen? Hmm? What will happen? It will just burst or not, it will blast. That's nothing but what? A single balloon is a method. A single balloon is a method. Four kids are nothing but four threads operating on the same balloon. So it is happening what? Wrong result. So neither of them can use that balloon. Finally, they got a problem. Shall we go for it now? Can I show you how it is going to be useful? Right. Okay, I will show you that. Let's start this. Now let us go for notes. I will prepare after a few minutes. By showing the program, I will prepare the notes, students. Let's open the note. Let's open this now. Let's go to the Python program. So I'm writing program here, non-synchronization, NYNCH, non-synchronization example one.py, .py. Now I'm taking one small logic, my dear students, which you already know about it, which you are already know about it. Yes. From threading, import star. Yeah. I will take one small known example only. I will take it because this is also an important area in the multi-threading. That's why I'm covering. Table. I'm taking table. Yes, students. I will take one n. What I'm doing there? Print off. Print off. Star 50. Star 50. Multiplication table I'm giving mark. That's it. So I'm taking multiplication table for print. Multiplication table for I'm saying that dot format of n. Dot format of n. Okay. Print of what do you know? 50. Now I'm going to say for I in range of 1 comma 1. Now I'm printing. What is it? N is already there. I will say backslash t. See carefully, students, all of you. Yes. Is equal to I'm saying is equal to I'm saying dot format of writing here n comma I comma n into I. N comma I comma n into I. N comma I comma n into I. Okay, ma. Kaushif, thank you. Kaushif, thank you. Else I am writing print of this, I'm writing. Yeah, else what I am writing. So this is after all one multiplication table I wrote it. Yeah, coming to the main program, I'm saying that T1 is equal to thread of, yes. Target is equal to table. Arcs is equal to, arcs is equal to, I'll pass fifth table. T1 want to generate. Okay. Similarly, I will take one more. See the speciality of this. T2 is equal to, both the threads want to enter into the table. This is called some 15th table you want. T3 table is there. T3 thread is there. I want the table. He want the 19th table. 19th table he want. Next T4 is there. T4 is there. And want to know ninth table. How many? Okay, Piyush, 25 or 25? 25 table is want. Like that. How many threads I want? How many threads I want? Come on, students, how many threads? I have 4. All the 4 threads are entering into which method? All the 4 threads are entering into which method? Table method, table method, table method. Can you give that which table will generate which entry here? Can you generate which table will generate which entry here? We can't. Start the threads. Just dispatch the threads. So start the threads. How do you do it? T1 dot start, T1 dot start, T2 dot start, T3 dot start, T3 dot start, and T4 dot start, T4 dot start. 4 threads we have. T1 dot start, T2 dot start, T3 dot start, T4 dot start. 4 threads we are starting. When you start 4 threads, then see that what will be the output of this program. Carefully try to see the result. And you only tell me the result of what it is. What it is. Go to the place. Go to the place. Mono. Result will come. But which type of result will come, you need to tell to me. Which type of result will come, you need to tell to me. Which type of result will come, my dear students? Which type of result will come? Incorrect result, wrong result, deadlock result, non-thread safety result, deadlock result, race condition result will come. Okay, come down to the command prompt, students. How simple it is. How simple it is. Z colon, here we are, Python here, and this is called what, 6 p.m. and say that threads here, py, I'm saying that py, writing here. See that answer, all of you carefully understand. Non-synchronization example 1, non-synchronization example 1, I'm writing this. Yes, observe all of you. See that result is like this. See that what is happening. Multiplication table for 5, only few entries came. Immediately one more thread came. 5 into 8, 20, heading is something. It is like this. Multiplication table for 19. See that. Multiplication table for 15, heading is there, but 25 into 1 is continued. 5 into 10 is continued. 19 into 1, 19 into 15, 19, 15, 19, 15, 19. Again 25, 15, 25, 15. What is this result is called? Again you execute one more time. It is not coming in the same order. It is coming in some different order. Unexpected result came. See, 5th table only few entries, 19th table not at all came in, 19 into 1 only. 25 again 15 is coming. Again 5 is continued. 19, 15, 19, 25, 19, 25. Like that, 5th table also mixed. It is called which result? This type of result is called what, students? Deadlock result, wrong result, non-thread safety result. Still, to show you the beautiful way, I will write a time dot sleep of 1 second. I will write it 1 second. 1 second I will write it. Still, you can observe it. Import time. You can say import time. See, students, how simple it is. See that result, you see how it is coming. How it is coming. Multiple ways it is result is coming. All the ways. This is the deadlock result. Deadlock result it is called. Do you need this result? Do you need such results? No, sir. We don't need this result, sir. Then how do you tackle this result, sir? That is one of the most important. Can I solve this result now? Imagine now. What is my function name now? What is my function name here? Table. What is my function name here? Table. DEF. I have the logic here. How many threads you created? T1 is the thread created. T2 is the thread created. T3 is the thread created. T4 is the thread created. When you say start, when you say start, How many threads are coming? Multiple threads are entering into the same resource at the same time. What result is coming? Deadlock result is coming. This is the result what we are getting. Such a type of result are unexpected, mismatched result is coming. To overcome this type of mismatched result, we must go for which facility? Locking facility, I must go for it. Which facility I must go for it? Locking facility. Locking concept I must apply. Locking concept I must apply. Are you understanding, my dear students? Yes. Shall I apply the locking on this area? Yes. What I should do? What is the locking? Same program I will take it, students. Let us apply. Let us see that. Let us see that. So here I will paste it. How many threads are there with me? How many threads are there with me? 4. 4. 4. Okay. 4 threads are coming to where? Which method? Table method. Yes or no? Table method. Okay. Let them come. Let them come inside. Let them come inside, 4 of them. But don't allow them to execute from here onwards. Let them come, no problem. Let them come to enter into the table method. They're only made wait. They're only made wait. They're only made wait until T1 is completed. Until T1 is completed. Who are waiting? T2, T3, T4. T2, T3, T4 made wait until T1 completed. T1 completed. Allow T2. T2 also completed. Allow T3. Allow T3. T3 also completed. Allow T4. For that, you need to go for lock. Lock is called one class. Once again, how many threads are entered? T1, T2, T3, T4. Who want to allow you first? Who came first? T1. Who came first? I will give lock to him. Lock to him. Once if I give lock to him, who is permitted only? T1 is permitted. Who is waiting? Who is waiting? T2, T3, T4 waiting. Until who will complete? Until who will complete? T1 will complete. Until T1 will complete. Until T1 will complete. Yes, my dear students. Next. Once T1 completed, once T1 completed, the lock, when you are entering inside, you are obtaining the lock. Once you completed line number 12, you are releasing the lock. You are releasing the lock. In line number 5, you are acquiring the lock. In line number 13, you are releasing the lock. Releasing the lock means PVM will give the lock to whom? Lock to whom? T2. T2 will acquire the lock and execute it. Acquiring the lock means no other persons are not allowed. Simple, ma. You are entering inside the room and keeping the bolt. Back side of the door, you are keeping the bolt. You do your operation, you are coming out of it by removing the bolt and coming. And you are giving the lock to another person. Like that, who is doing that? Allowing the person, PVM is observing it here, allowing, releasing, acquiring, releasing, acquiring, releasing, acquiring, releasing. Shall I do that? In Python programming, there is an object called a lock. There is an object called a lock. Yes, Kotesh. Exactly. Voting. Yeah, voting. Exactly, voting. Come on to that line number 4. I will create L is equal to some object. L is equal to lock. Lock is a class. It is a global variable I created. Which variable it is? Global variable. Global variable it is called. Are you understanding? It is a variable created before all my things. Global variable. I created an object of what? Lock. It is called what? Create an object of what? Create an object of what? Lock. Lock is a class present in which one? Threading module. Are you understanding this statement? Creating an object of lock. Where I have to implement the locking facility? Whichever entries are giving wrong results, such a type of entries you need to prevent from the deadlock result. Such a type of statement should to be executed by the threads all at once. No, we want to execute the statement one thread at a time, so that inside of it you acquire the lock. L dot, there is a function called acquire. Acquire is a function. Line number 6, you observe, ma? All the things for all of them are entering inside the line number 5. How many threads are coming? 4 threads are coming. 4. You are acquiring the lock. Who will acquire the lock? T1 is acquiring the lock. And who are waiting? T1, T2, T3, T4 are the threads are waiting. T2, T3 are waiting until who will complete? T2, T3, T4 are waiting until who will complete? Acquiring, execute the statements. Line number 15, do you know what I am doing? While I am coming out of it, T1 dot release. See how easy it is? Release. Line number 6, line number 5, 15. Line number 4, create an object of lock, acquire the lock, release the lock. Enter inside the room, keep the backboard button, and while coming out of it, release the button and then come. What are the functions in lock class? What are the functions in lock class? Acquire class and what? Release class. Release, acquire function and then what? Release function. Present in where? Release is a function eliminating the lock on it. L dot release. Taushif. L dot release. Release is a function available in the lock. Here you are locking, here you are unlocking. Understanding? Here you are locking and you are unlocking. Taushif, are you getting ma? You are keeping the question mark for release. L dot only. L dot only. L dot acquire. L dot release. This is called L dot release. L dot release. It is called L dot release, not, yes, L only, that is. L1, L1. L dot release. L dot release, not T1 dot release, ma, L dot release. Whoever is entering, acquire the lock, this is get the lock and unlock. Get the lock, get the lock, get the lock, get the lock. On which function? Table function. Get the lock on the table function. And release the lock on, release the lock on, release the lock on, release the lock on which function? Table function. Release the lock on table function. Did you understand? Create an object of lock. Create an object of lock. Create an object of lock. Create an object of what? Lock. So, coming to the point of it, now let us see, I will take it as what? Synchronization example 1. Did you understand the flow also? Did you understand the flow also? Did you understand the flow also? Yes, very good. So let us coming to the point back. Let us coming to the point back. Synchronization example 1. Synchronization example 1. Now, I say this, PY, synchronization example 1. Now I'm going to give you the clarity here. So see, execution I'm giving it. See carefully how it is done. See that, carefully observe it. What is happening? First table is called what? Who is operating? Tell me quickly, who is operating here? Who is entered? T1, super. Next, see, T1 released the lock. Who obtained the lock now? Who obtained the lock now? T2, super. Super. Who completed now? Who completed now? Yes. Who obtained the lock now? T3. Beautiful. Beautiful. Yes. Yes. Good. Good. Super. Super. This is. Still, I will show you more important word. More important word. Yeah. Go back to that. How is this result? How is this result? What is this result is called? What is this result is called? What is this result is called? Consistent result. Consistent result. Yes, ma, Jafar, that only. Yeah, flow also I will write it. Right, let's go to that. Let's go to that. I will write one mechanism here. Multiplication table. See, ma, see, I will write it. Right. What I am writing is, I will write obtains lock. Obtains lock on table function. Who obtains the lock? I am going to give you. Dot format of current thread underscore thread current thread dot name current thread dot name obtains lock on table obtains lock on table current thread dot name obtains the lock. I'm printing the thread name, students. After this is done, I'm writing obtains, releases the lock. Which one? Releases the lock on table function. Who is that? Same thing. I am obtaining the lock, releasing the lock, obtaining the lock, releasing the lock. Execute now. See that you will understand more for perfect. Jafar, see my dear student. See, thread 1 table function obtains the lock on table function. See that? Who are waiting? Thread 2, thread 3, etc. Now you see the answer. Thread 1 releases the lock. And who obtains? Thread 2 obtains the lock. Beautiful. Extraordinary. See, thread 2 releases the lock. Thread 3 obtains the lock. See that? Obtains the lock on table function. Now, thread 3 also completed. thread 3 complete. Thread 4 obtains the lock on the table. Beautiful. Yes, completed. All the threads are collected by whom? All the threads are completed by whom? Garbage collector. Yes, sir. If you want to see T1 dot join, T2 dot join, and T3 dot join, and T4 dot join, and I say that program execution completed. Program execution completed. Yes. See, you see that last and final. So you are getting that. You are getting this result. See that result carefully. Last you will get what? Last part you will get it. The result. Yes, done. 25 last table is coming. Is it easy to understand or difficult to understand, students? Is it easy or difficult to understand, students? Simple, sir. Easy, sir. This is. What is the class we are using? If I remove the sleep method, here, all of them are coming at the same time. Look at, all of them will come at the same time. We got the same result. We never feel that they are executing even one by one. All of them are coming, obtaining the lock, releasing the lock, obtaining the lock, releasing the lock. What a beautiful answer it is. I removed it. Within the fraction of seconds it is completed. Yes, I got it. In a fraction of seconds, I got it. Are you following? Right? Within the fraction of seconds. You want to see that execution also? Yes, so you see BT is equal to time dot time, time dot time, and ET also I will write it, students. ET also. You see, students, ET also I am writing. ET also I am writing. Beginning execution, ET writing here, and then print off Execution time is equal to dot format of et students. This is et. I will write it students, et minus bt beginning time minus this is minus. See students how easy it is. Execution time, last point I'm writing, last point. See students, I'm writing what is an execution time, 0.01639 etc. See how easy it is. It is not taking 1 second. 0.0. See how fast they are. How fast they are. Did you understand this mechanism? They are interfering into the same place. They are interfering into the same place. See, obtaining, releasing, obtaining, releasing. What a beautiful example. See, ma, how much fast or not? Yes. Is the locking concept is useful or not? Yes. Locking concept is useful. See, I will remove this lock. I will remove this lock. I will remove this lock once. I will remove this lock once. See, locking function I will remove. Then you see what is happening. You got it. You got it. Wrong result came. Wrong result came. Everything is wrong. Yes. Yes, Ma Saifuddin. Exactly. It's a faster than our imagination. Super. Saifuddin. Very good. Keep it that word. Faster than our imagination of our calculation. Super word that is. See, this is the result. Still, okay, faster. But what? Wrong. So to avoid that, this type of situation is required. So students, see my dear students, how easy this is. So what is the class name? What is the class name I am using? What is the class name I am using? Okay, 1 minute. What is the class name I am using? This is called, this one is used. Lock class we used it. What are the functions we used it? What are the functions we used it, ma? What are the functions we used it? Release function as well as what? Acquire function we used it. This is called synchronization example 1. Okay, right. Let me close my screen. I'll go to it. Something is happened there. Yes. Z colon. So 3 steps are there. Obtain the lock. Obtain the lock. Create an object of lock. What is that? Python 6 p.m. and say what is this? 6 p.m. and I'm saying what? And I'm saying what? Function. This is called threads. I say py. Our example is called what? sync synchronization example 1.py. So yes, ma, something is happening there. Line number 6. Okay, acquire that. Acquiring is important. I did not acquire. Yeah, that's why this is coming. Releasing, still it is not possible. Okay, I forget to uncomment that. Now you got it. Okay, students. Let's go to that Z colon last and final P Python and then 6 p.m. and say threads, then see py, and this is called what you know, synchronization syncc example 1.py. See that results are coming and well, that is well done result. Students, did you understand the importance of locking mechanism? Is locking is difficult? Is locking is difficult? No, easy, sir. It is a dead easy. See the flow also I'm showing it. Flow also I'm showing it. Yeah. Let's go to the, see, instead of typing from my side, I just want to take my previous batch documentation, what I taught. See, I just want to take up this wording. I just want to open it. Same thing, of course, it is the same thing. What I said, same thing will come in front of you. See, students, instead of typing and all, watch this. Synchronization or locking and unlocking. When multiple threads are operating or working on the same object or resource or method, understand? Whatever I explained, same thing I put it into the notes. When multiple threads are operating or working on the same object, resource, or the method, then by default we get which result? Which result? Deadlock result, race condition, wrong result, wrong result. That is non thread safety result, non thread safety result, non thread safety result, incorrect result, inconsistent result. There are a lot of words are there. To overcome this deadlock result, industry is recommended to apply synchronization concept. That is nothing but a locking concept. Synchronization, nothing but what? Locking concept. The advantage of synchronization or locking concept is the advantage of synchronization or locking concept is that to provide what result? Thread safety result. Nothing but consistent result. That is nothing but accurate result. Accurate result. The advantage of synchronization or locking concept is that to provide thread safety result, consistent or accurate result. In Python, is this term is okay? They will ask you a question. What is the use of synchronization? What is the use of locking? You have to understand this part. You have to understand this part. Super. In Python, we can obtain the synchronization by using locking and unlocking concept. What are the steps? First step, you know easily, create or obtain an object of lock class. How? Example, L is equal to threading.lock. Lock is a class. Present in which one? Lock is a class. Create an object of lock class. Of which module? Threading module. Of which module? Threading module. Threading module. Okay, that's why we are creating L is equal to threading.lock. Even in our program, L is equal to lock off. Why? Threading import star I said now. That's why. Did you understand? Yes. Next, to lock the current object. To obtain the lock, to lock the current object or what? Method. We must use which function? We must use acquire function. How do you do that? L dot acquire. L dot acquire. To unlock or release the object or method. Yes, we can use what function? Release function. Release function. Easy? Is it easy? Students in the class, is it easy? Yes. Fine, students. To unlock, 3 steps. What is the first one? Dead easy. Yeah, Piyush, good, dead easy. Create an object of lock, acquire the lock, release the lock. In the ATM center, only one person can enter and operate only one machine at a time. Only one machine at a time. Did you understand, my students? So what is the topic we understood? Simple, easy topic and most powerful topic. In you see, any student of Python, you take a student, they don't know multi-threading. They don't know whoops at all. They don't know regular expressions at all. Most of the topics they don't know. Just check by yourself. Create, yes, Meghraj, exactly. Create an object of lock, acquire the lock, release the lock. That's it. And I'm using in this example. Yes, ma, Tausif, I will show you. I will show you now. Yesterday's steps, yeah, maybe I explained the program, right? I explained the program or not? Yes. No problem. After this, I will show you that. After this, I will show you. Look at all of you. Look at all of you. This is an example of synchronization on where functional programming. Am I correct? This is the lock object on where functional programming. Am I correct? Yes, sir. This is the locking object on functional programming. I want the locking concept on where? I want the locking concept in where? Oops. Yes or no? Oops related locking I want. How it is? How it is? I want to know the oops related example I want to tell you. Oops related example I want to tell you. This is called what? Non-synchronization example functional. Non-synchronization example functional. This is non-synchronization example functional. This is. Now I want to go for like what? Oops related example I want to go for it. Let me talk about it. This is called a non-functional. So I write it functional approach. Functional approach with what? Non-synchronization. Here synchronization is what approach? Functional programming this is. Functional programming this is. Yeah. This is called what? A non-synchronization with what? Functional approach or functional programming. Yes, we got it. Dear students, this one, I want to go for with oops. How do you do with oops? I'm just going to tell you that. I'm just going to start with the oops. How to do it, sir? Very, very simple, sir. Let us go to that, sir. I will take. Look at students. Non-synchronization. Look at class. MUL table. Of course, MUL table. Example or class name. MUL table or multiplication table or whatever it is. Multiplication table 1. I say done. DEF table function I will take it. Table function as usual I will take it as n. Same to same. Nothing is difficult. Same to same. Nothing is difficult. Only thing is self comma I wrote it. Self and I wrote it. Okay. Formal parameter itself I can move forward. What I did? Same to same I will write the logic. Whatever the logic I wrote here, same logic I will write it. No locking here. No locking concept is applicable here. Yes, see students, all of you. Table function. Approach number 3. Kaushik. Approach number 3. Main program. Yeah, look at what I do. Create a thread object. How many thread objects I want to create? Create an object. Four threads. T1 is equal to thread of. Of course, I need to take it from threading. Import star. From threading, import star. I am saying. Yes. Now I will say thread of target is equal to empty dot table. What is empty? Arcs is equal to, last class also I told you, some fourth table I want. I am saying that empty is equal to MUL table of 1. Empty dot table. Empty dot table. Next, T2 is equal to, next T2 is equal to, I will take it some type of value that is called 14th table. T3 is equal to, I will take it as something like a 19th table. 19th table I will take it. Next T4 is equal to, I am applying something like a third table I am applying. Yes, ma, in banking sector, in insurance sector, in online banking, in online websites, this locking concept is most useful. Yes. Now you say start. T1 dot start. T2 dot start. T3 dot start. T3 dot start. That is nothing but T4 dot start. T4 dot start. T4 dot start. T1 dot start. T2 dot start. T3 dot start. T4 dot start. When you say start, 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 what is happening? You just observe it. No locking, nothing. All of them are entering into where? See that students, all are targeted to table only. All are targeted to table only. Oops related deadlock will come. Oops related deadlock will come. How easy? Let us save it. I'm writing non-synchronization example 2 dot py. Dot py. This is called oops. Oops, oops, object or oops principle I have applied. Oops principles I applied. Okay, students. Oops principles I applied. Let us save this code. Let us save this code. Yes, done here. Example 2. Non-synchronization example 2. Py. Non-synchronization example 2. What is happening? Time dot. Okay. Time. Import time also. Okay, let me take up import time and take care students all of this. Time dot sleep, time dot sleep, time dot sleep. Save it. Yes, go there. Py. Yes. See the result students, all of you. Fourth table, 19th table, third table. These are all called which result? Which result? See what result it is? Deadlock result. What a dangerous result it is. What a dangerous result it is. Are you getting my point? Very good. Very good. Students, let's move to the further. Can you solve this issue? Can you solve this issue? Yes. This issue must be solved so carefully. This issue must be so solved carefully. Right. Yeah. See, students, don't go like a functional programming like. Don't go like a functional programming like. What we do is, in object-oriented programming only, see, whenever I created an object, obtain the lock. Whenever I created an object, obtain the lock. What you will do, tell me. Whenever, see, listen my words very carefully. Whenever I create an object of MUL table, obtain the lock. How many lock objects? Only one lock object I want to get it. How do you get that? Come on, quickly I want to know. Whenever I create an object of MUL table 1, I want to obtain a lock. How do you do? In my word only, there is a pointer. No, ma. See, whenever I create an object, obtain the lock. How do you get it? Simple. See, everybody is entering into empty object table, empty object table. In that object they are entering and table they are entering. Ah, Tausif, mono. Very good. Constructor we need to define. Super. DEF underscore underscore init underscore underscore of self. Right. Self. Only. Yes. What I do? In that you create an object. How do you create an object? Self dot L is equal to lock off. Lock off. Self dot L means in the current object, lock object is there. In the object, lock object is there. In the empty, lock object is there. In the empty, lock object is there. When T1 is entered, in the empty, put the door. Put the door. Bolt it. T2, when T1 completed, release the lock. In the empty only release. Acquire and release. Acquire and release. Acquire and release. Did you understand, students, all of you? Easy, students. Dead easy, students. Okay, come on to the point of it. Now tell me. In this point, I want to acquire the lock. Tell me how to acquire. I am waiting for the statement to understand. Yes. Earlier, what you have written? L dot acquire. You have written, right or not? Now, how do you write it? No. Tausif. Super. Self dot L dot acquire. Self dot L dot acquire. Beautiful. No mono. Only see self dot L is an object now. Dot acquire. because L is an object of instance data member, you took it. Self dot L is equal to acquire. No, ma. Omkar, no. Because identity must be, same ID must be there to the object for entire thing. If you create differently, it is going to create different lock objects for different students. That is why different students are entering into different rooms. Different rooms. Omkar, different rooms. It's not good. It's not possible. Different IDs will come. Same ID. I want to acquire for everybody. Understand? This is not I am doing self.n. Piyush. It is called n only. I am using formal parameter directly. Formal parameter directly I am obtaining. Formal parameter directly I am obtaining. Right. Shall I execute? Now here I need to release the lock or not? Release the lock. How do you release? Once L spot is there, how do you release the lock? I forget. Self dot L dot release. Self dot L dot release. This is my function. Self dot L dot release. It is my function. Acquiring the lock and then closing the lock. Here what is doing? Here what is doing? Get the lock. Get the lock. Here you see in this place, get the lock. I'm saying that get the lock. And next is called what here, and release the lock. Release the lock. I'm saying that release the lock. I'm saying that release the lock. And here what? Create an object of lock. Create an object of lock. It is nothing but create an object of lock. I say here, create an object of lock. Yes, beautiful. Create an object of lock. Wonderful. Are you okay? Create an object of lock. Get the lock on the table. Get the lock on the table of empty object. Of empty object. Of empty object. Table of empty object. Next, release the lock of table function of empty object. Empty object. That is called self. Execute. Did you understand? In the constructor, I had a lock. I am acquiring the lock and releasing the lock. Come on. Follow. Once an object is created, yes, Omkar, I am telling that only. So far that only. Empty constructor is created. Constructor created means what? It will go to the constructor. Lock object is ready. Lock object is ready. Whenever you say this one, T2, T1, this is executed speed they are executing. All of them are entering into this place only, this place only, this place only, this place only. Who will get the lock first? Who will get the lock first? T1, 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 T1. T2, T3, T4 made wait. T2, T3, T4 made wait. Until who will complete? Until T1 completes. So here also I am writing thread name, etc. Thread name, etc. Very, very simple. If you want to give your own name, you can write it. T1 dot name is equal to T1 dot name. Thread name I will write it. Row sum I am writing. Row sum. Row sum is obtaining the lock. You want to generate fourth table. T2 dot name is equal to Gosling. You want to generate the logic. T3 is equal to T3 dot name. Thread names also I am giving. Is Richie. Richie want to obtain the lock. And T4 is equal to T4 dot name is equal to, I am assigning the name to the thread, is equal to Travis. Travis, I am writing. Single quotes, double quotes, I can write. These are all called what? User-friendly names to the thread. User-friendly names to the threads. User-friendly names to the threads. Beautiful. User-friendly names to the threads. Save it, and execute. See, my dear students, execute this. Synchronization example 2. Synchronization example 2. Here I will write it. Synchronization example 2. Yeah. Execute it. It was saved on what name? It was saved on non-synchronization example only, na? Okay. Okay, no problem. It was changed in the same place only. It was saved in the same place only. Don't worry. So this is non-synchronization example one. And then in the I for that synchronization changed. And this is how I do this. And see once if you want, I can take it. I can take it. 1 minute. If you wait, I will show you that. Python, I will paste it. I'll paste it because don't get confused with this. Synchronization example 2. Synchronization example 2. And this part you see, I don't write this constructor. I don't write this constructor. I don't write this self dot acquire. I don't write this thing. And I just return this. User friendly names only. This is non-synchronization example 2. Non-synchronization example 2. Okay. Now synchronization example 2 is this one. Non-synchronization example 2 I will execute once again. Non-synchronization example I will execute once again. You want to see? Yes, you can see. Non-synchronization example 2. See that deadlock result is coming like this. See ghostling like that. All of them are obtaining the lock and then not able to do properly. The result is coming like that. See that beginning. Rosam obtains the lock. Travis obtains the lock. Richie obtains the lock, but are unable to execute them properly, interfering to each other. Let's execute synchronization example 2, students. Synchronization example 2. See, my dear students, Rosam obtains the lock and doing perfectly. And other people, Gosling, Richie, Travis are waiting. Yes, Gosling obtains the lock on the table, enter into the room, doing the multiplication table, generating, and coming out of it. Yes, coming out of it. Yes, Richie got a lock on the table and then doing the operation, coming out of it. Coming out of that. Travis obtains a lock on the table, got it. Yes, obtains the lock, perfect. Is it okay, students? Are you perfect in this locking concept? Very good. Now, last class, maybe this is the one what you are asking about it. Now, let us do your place and I will upload that concept also for you. I will upload, right, concept also for you. Let us coming to the in this place, threads place, approaches, number of approaches which I to study, and I think so. Last class, I just mentioned, I think so. I mentioned it. First approach is done. Second approach is done. Third approach, I think so. Maybe I mentioned it. I just written the steps like this. Import the threading. Even in our case, also done the same thing. Choose import threading. Define the class. Define your own method. Define your own method. Tomorrow morning, class is at 7 o'clock tomorrow. Tomorrow class is at 7 a.m. 1 minute. I will write it. Tomorrow at 7 a.m. 7 a.m. 7 a.m. Sunday, that is. Tomorrow, Sunday, 7 a.m. to 9 a.m. Topic name, last topic is called network programming. Actually, this is not necessary, but still I want to tell you, network programming tomorrow. Actually, it is not necessary because Django is required. Why Django is required also, I'm going to tell you tomorrow. Right? So this will take tomorrow and Monday. Tomorrow and Monday. Monday also I will take. Why I am taking tomorrow is because once we go to the offline class, it will become delay to coming to the class. That's why I am taking tomorrow. Actually, I told you from the beginning, 20th will be our last session. So that's why I'm taking tomorrow and Monday. So Monday timing is, look at Monday. All of you listen. Monday timing, it won't take much time on Monday. Monday timing is 6:30. I will take the class. 6:30. 6:30. I will take the class. 6:30 p.m. to 8, 8:30 p.m. This is my timing on Monday. Continuation of network programming. Network programming. That is the last class. Last class, that is. Monday will be our last class. Okay? Yes, ma. Any such drives are there, we will intimate, ma. We will intimate. So, yes. Yes, ma. Further Django batches and all those things, please consult to one office once. Right? Right, ma. Definitely, ma. Riyaj. I will tell about my biography. Okay. Right. So, Monday, we will discuss some chit chatting we will do at the end of the class. Once the class is over, I will go for it. Right, ma. Megharaj, thank you. Thank you. A good association with you people. Okay. So, tomorrow, what is our timing? Tomorrow, what is our typing? What is the timing? 7 a.m. to 9 a.m. What is the topic name? What is the topic name? Network programming is our topic name. Network programming is our topic name. Okay, na? Right. Okay. Now see students, coming back once. See that third approach, non-subclass of thread class. Define import threading. Choose the programmer defined class. Choose the programmer defined method name. And we must define the logic which is executed by our thread, which is executed by the subthread. Tausif, Seema, all of you. Tausif, all of you look at. Right. So this is what even today's class also. Define the class, define the programmer defined method with the logic executed by the thread. Same approach also we did here. And a simple example also. Class KVR operation. First step is this threading. KVR class and a method. I am going to do K is equal to KVR. Target is equal to K dot operations. And I am giving K name DROM and a start function. So this I will upload. I hope this I did not upload yesterday, right? Today I will upload it. Okay, students. Am I clear about my explanation? Is this multi-threading is, are you confident? Are you confident in this multi-threading? Yes. Yes, very good. Very good. So today I will upload all these programs and I'll stop the class now. Monday we will go for the class. Yes, ma. Omkar, because of I have so many batches, because of that only I'm unable to handle too many batches in the day. Too many batches in the day. That's why we are going for this type of thing. Okay, because too many batches are there. I'm unable to take too many batches in a day. That's why we are just dealing with this. Okay, right. Students, shall we stop the class? Yes, ma. Shubham. Screening test. Please expect it in the next year. We hope that we will get some good campus screening test will take place in our place. They are just trying like anything from most of the companies. Most of the companies. If you wait once, I will show you one small point for you. All of you wait, and I will show you one beautiful message of our student, how they got it, and all those things. Just for a minute, you wait it, ma. All of you. I'll show you, and definitely, right. You will get a very good job. You will get it. There is no doubt in that. But 1 or 2 days late, that's it. Nothing to happen about it. Nothing to happen. Nothing to stopping you like that. You will get a beautiful jobs. There is no doubt in that. Keep in mind that what sir said that. But read well and program it well. Definitely, ma, we will intimate. See, students, all of you. This is one of our student. The total family belongs to our class. It seems. In the past, so many years, I'm in the teaching field. See, because of 25 years of teaching experience, so many people are belongs to our class. Good evening, sir. See that thank you very much for your teaching and guidance. I'm Pavan. I got placed the offer letter from TCS today. Yesterday's message this is. So I'm Pavan. I got the offer letters from TCS. From my family, 4 members, my 2 sisters, my brother. We were taken Java training under you. All of them are under me, Java, and taking Python training under you, sir. They are also belongs to my Python. He is the person. Pavan is taking both Java as well as Python. And my sister Monica is doing her job with 15 lakhs. Maybe she was my previous student of 1 or 2 years back. Second sister Malati doing her job with 7 lakhs. And my brother Srikanth is doing his job with 25 lakhs. And now I started with 3.3 lakhs. This is the student of my class. So this is what I said. This is what the student, because of long things in the teaching career, many of our students who are placing in very big companies. So this is more happy. One family, all brothers and sisters are doing like this, right, students? Like that, you have seen so many success stories from our class. You also do well, and you are also good placing in definitely in good companies. Coming days only Python. Remember, students, coming days only Python. Don't worry, you'll get very good jobs. Practice well and do well. I hope I gave my number to you, all of you. I hope I gave my number to all of you. Everybody is having my number now. Yeah, keep it with you. Any kind of clarity, doubts are there, any career related queries are there, you post me. In my free time, I will respond. Right? Yes. Yes, ma. I told my number na. I will just give my number to everybody. I'm typing in my chat window. Yes, I'm typing in the chat window. Please receive all of you. Yes, I'm sending to everyone. Please ensure it. You have received it. Right? So please preserve it. And any doubts related to query doubt, once you get a job, please intimate me that you got a job, so that it is a motivation for the upcoming students. Right, students? Right. Thank you, Madhushita. Now, can we stop the class? Can we stop the class? Tomorrow, what time? Tomorrow, what time? Yes, students. Yes, ma, Ananda, don't worry. You will be getting placed in nowadays. You will be getting lot of opportunities coming. You see, 2022, everything is Python. Total world is running behind of Python. Please be ready with your practical knowledge. Be ready with your practical knowledge. Prepare my notes thoroughly. You will be the number one person. That's it. Okay, right. So we will meet tomorrow, Sunday, fine morning, 7 a.m. Network programming I will start. Thank you. Good day. All the best.